Hello everyone, I'm Vijaya, and today in this session we are going to discuss about the theory of origin of the solar system, how the solar system is originated. Okay, theories about origin of solar system. Okay, so before we discuss about what is the solar system, the board is not clearly visible to you because of the setting, but we will adjust that. Okay, so first of all, let us understand what is a solar system. A solar system is a gravitationally bound system. Now, what do we mean by a gravitationally bound system? Suppose, wait. Okay, now I hope I'm visible. Okay, now what do we mean by a solar system? A solar system is a gravitationally bound system. Gravitation, remember the term gravitation. Now, our Earth. Okay, this is say our Earth. We have, it's not clearly visible, right? Okay, so let us assume that this is our Earth. Okay, this circle, this is our Earth, this is our Sun. Okay, now we are all gravitationally, the Earth pulls us towards itself gravitationally. There is a pull, so we are not flying away in the air, you can say. So first things first, our solar system is a gravitationally bound system. Our Earth has a gravitational pull of its own. The Sun has a gravitational pull of its own. So, you know, the various other planets, they are rotating around the Sun on its axis. So what it is a gravitationally bound system. And it was formed about wait a minute. Yeah. So it was formed about 4.6, remember the term 4.6 billion. Okay, it was formed about 4.6 billion years ago. All right, 4.6 billion years ago. And yeah, these are the basic terms that you need to know. And now regarding the theories about the origin of the universe, there has been 8 theories that are given. Okay, Nebular hypothesis, gaseous hypothesis, Big Bang theory. We have all read about, especially the students who are from geography, right? We have all read about the Big Bang theory in our class 11. But if you have not read about Big Bang theory, no worries, we'll read that also. There is this nebular hypothesis, we have gaseous hypothesis, we have Big Bang theory, we have plate tectonics theory, from where plate tectonics theory is particularly very important because questions come here from, be it for your CUET exams or NT exams, or you know, questions come from the plate tectonics theory. So first things that we are discussed about today is we have the gaseous hypothesis of Kant. Gaseous. The board is not visible, but I hope whatever I'm saying to you makes sense to you a little bit, even if it's a little bit. Sorry, my throat is. So now gaseous hypothesis. This gaseous hypothesis, it was given by Kant. Okay. Now what does this gaseous hypothesis say? According to the gaseous hypothesis, there was a big, you can say, ball of gas. Suppose, imagine I have a ball in this hand, okay, a ball. Now in this ball, we have got, okay. So this ball of gas, this is a solid motionless particle, okay. I'm explaining from the copy because I'm not an expert myself, but I'm trying to teach you whatever I know, okay. So see, we have, wait a minute, we have a ball, okay, we have a ball here, and then it is filled with particles which are motionless. It is motionless, it is not moving, okay. In suppose in the Earth atmosphere we have various gases and all, right? So likewise there is a ball where there are various kinds of gases which are cold, okay. These are cold and solid, and it is not at all moving, okay. But suddenly what happens, suddenly means gradually over the years, this cold which was frozen, it did not move at all, but it slowly started rotating, okay. Why? Because of Newton's law of gravitation. First things first, the particles, it was pulling inside, okay. See, there are these particles spread over, okay? The particles are spread over various areas like this, like this, like this, okay? Now there is this gravitational pull that is pulling it towards itself. Now we have Earth's gravity, right? It is pulling us towards itself. That's why we are intact. We are intact to the Earth's surface. We are like, no, we are not flying in the air, right? So this gravitational pull, it keeps us bounded to the Earth's surface, okay? This gravitational pull, because of this gravitational pull. In this gas, there's this gravitational force that is bounding us, and then another force applies here is this rotatory motion. First of all, the gravitational pull starts acting, and then the particles, they start rotating, okay? They start rotating, moving around. Okay, so because these two principles are applied, and because of which the hot gases, not hot gases, it's gases, okay? Cold gases, the cold gases which were earlier not in motion, they start moving because of the gravitational pull and the rotation, okay, and the rotatory motion. So now what happens? It was a cold mass of gas. Now it has started rotating, and the heat is also increased, okay? Obviously if it starts rotating and the particles will collide, then ultimately the tension between them will increase, the heat will increase, right? So yeah, temperature increase, the motion increases, and as a result of which this particular ball of gas that we had is now, it has now started expanding, okay? Like suppose if you rotate something, it will gradually start expanding like this, right? So this ball of gas, it has now started expanding, and it has started forming axis, okay, around it, through which planets are formed. So this is the first hypothesis. It was given by Gaseous, Kant in the year. Remember, if you want to make notes, you can do it like this. In one column, write the theories, and in the other column, write the propounder, who gave the theory, right? The propounder's name, and you can also write the year just to remember. And another very important, very important thing is the book in which the theory was given, okay? So for example, the gaseous hypothesis of Kant, it was given in the book The General Natural Theory and Natural History and Theory of the Heaven, okay? The General Natural History and Theory of the Heaven. So this in this book, the gaseous hypothesis of Kant was given. Kant gave the gaseous hypothesis in this book. I'm telling you the name of the book again and again because it is very much essential that you remember the name, okay? Now, Nebular hypothesis of Laplace. Let me just conclude with this one, okay? Because these two theories are quite similar. Nebular hypothesis, in the gaseous hypothesis, what happened? There was a ball. You can say there was a ball, and it had cold particles around, which were in stationary motion. And later on, it started rotating, and gravitational pull, and then rotation. All right. So now, in the nebular hypothesis, what happens? We have a cloud of gas again. Okay, a ball of a cloud of gas again, but it is hot. Earlier it was cold, but in the nebular hypothesis, what happens? It is a hot nebula. Okay, hot gaseous nebula. After it starts rotating, and then it forms rings around it, and this is how planets are formed. Basically, in the gaseous hypothesis, there were cold gases which were stationary. In the nebular hypothesis, there is hot gases. Okay, hot gases. Now, nebular hypothesis, it was given by Laplace in the year 1796. I will write it even though the board is not visible because I need to adjust the settings, okay? But for now, just bear with me, okay? I will try to mention it somewhere in the screen if it's possible, okay? So this, the nebular hypothesis of Laplace, it was given in the book Exposition of the World System. Exposition of the World System, okay? And it was given in 1796. And the gaseous hypothesis, it was given in 1755. Okay, so there are 8 important theories about the origin of the solar system or origin of the universe. The Big Bang theory, and the Big Bang theory is very popular. We have all heard about Big Bang theory at some point or the time or other. And the most important one is the plate tectonics theory. Okay. We'll discuss that in detail too, just like we discussed this gaseous hypothesis and nebular hypothesis. Let us do a quick revision. The gaseous hypothesis was given by Kant in 1755. There were two. There was a cloud of gas, a circle of a cloud of gas. It was cold, and later on it started moving because of the gravitational pull, and because of gravitational pull and rotatory motion. And other thing is the temperature started increasing, the velocity, the angular velocity, and as a result of which rings formed around. The nebular hypothesis is also quite same, except that the nebular hypothesis, it was formed of hot gases, unlike the gaseous hypothesis. So yeah, this is it for this video. Keep watching for more. Thank you.